Yeah.
Okay, all right. And I don't know how much of this might be blocked out. I'm not quite sure, but I'm going to try to minimize that as much as I can. Excuse me. Hey, I found my sheet. Good luck. So this is a picture. Everybody's probably familiar with this. This is my view from the back seat at K-21 at Hood River. That's me sitting up front there. But hopefully you will be sitting in front of me and we can do some flying together. I'm excited to do some more flight instruction. So my name is Steve Frisbee. I've been flying for a long time. I just recently became a CFI in gliders. But I have quite a bit of experience. I got my glider rating initially as a transition from powered planes about 20 years ago. And I've always loved flying gliders, and I'm glad that I had an opportunity to get back into it here in the Hood River area. It's a great place to fly, and it's a great club. So, so my experience in aviation, grew up in a family. My dad always wanted to fly, never was able to, but he had several sons who were able to get their pilot's license, and he's got a whole bunch of grandsons now. My dad's gone, but he's got a lot of grandsons that also pursued flying. So it's a real popular thing in Alaska, because if you want to get around in Alaska, that's one of the only ways to do it. So started flying in Alaska, got a fair amount of experience flying in the bush, flying on skis, tundra tires, landing on beaches, mountaintops, gravel bars, those types of things. So I've had quite a bit of experience and a lot of fun with that. When I first got my pilot's license, I bought a wrecked airplane and rebuilt it. Don't have it any longer. I decided that I wanted to fly lots of different airplanes. So owning my own plane wasn't necessarily conducive to getting experiences in a lot of other planes. So I did sell it. But, there's a picture of it. It's got tundra tires on it. And this is taken off from a gravel bar in the Alaska range. And I used it, although I'm not a hunter myself, I used it for putting people in and out of hunting camps around Alaska. I was out of flying for about probably about 5 years, hadn't flown much, and decided that I was going to jump back in with both feet. And my nephew, who's a first officer for Alaska Airlines, encouraged me to get back into it. I kind of was his mentor early on in his career, and he encouraged me to get back into it. So 2 years ago, I got my multi-engine rating in this twin Piper Apache. And I work in Prudhoe Bay, Alaska, which is way up north on the Arctic Ocean. And here I'm standing on an ice floe, one of the very few places in the world that you can walk on the ocean. It freezes up in the wintertime, and then it thaws in the summer. But here I had an opportunity to take a boat ride out to the ice floe, and the captain gave us a free ride out, but he said he was going to charge us to get back on the boat and take us back to shore. Fortunately, he didn't really. He was just joking. But and Prudhoe Bay, for those who don't know where it's at, you can't get much further north than where I am. And here's on the map, right up here at the very top of Alaska. You've maybe heard of Point Barrow, and that's right over here. And Prudhoe Bay is up here. The vast population of Alaska lives right down in this lower southeast Alaska. That's what the Anchorage and the majority of Alaskans live. But that's where I'm at right now. So if you're having any trouble with the Zoom transmission, our internet is not necessarily the greatest, but please let me know if you are. And if anybody can chime in, let me know how this is going so far, if you're getting these.
Just fine.
Great, appreciate it. Thank you. Okay, so this course is sailplane pressure instruments. Really, these are pressure instruments, not just for sailplanes, it's for all aircraft. When you go to take your written exam for the FAA, for private glider, they have questions there that are both for gliders and for powered planes. So there's going to be some crossover there. So we're going to talk about some things, some instruments that you wouldn't see in a glider, but presuming you're probably going to carry on and maybe fly powered planes as well, it will be important for you to learn about these as well. So that's one caveat to this class. During this class, we're going to learn what the pressure instruments in an airplane or glider are, and what they measure, how the Pitot-Static system, and that's the system that powers these instruments or gives them their indications, how that works, how it's laid out, the terms and principles relating to the altimeter and airspeed indicator, how or what can cause the system to fail. It's important whenever you discuss an aircraft system is to know how it works, but then also know what common ways it could fail. So if you're flying and have a problem, you can diagnose it as a pilot, see if you can mitigate that or know what to do if it does fail. And so this is also how to identify a failure and why it's all important to you as a pilot. So what I did have now, I'm gonna have to have everybody kind of chime in here and let me know if they were able to open up the Slido link for questions. You can go ahead and
I
unmute.
see the Chrome tab, but that's about it.
Okay, so if you've logged in, what I will do, we've got a couple opening questions here. So I'm gonna back up if possible. Okay, so this is a pre-course question, quiz question. So it's kind of get you start thinking about the course, but also for us to test a little bit to see how the quiz is going to work. So has anyone not been able to get into or click on and get to the Slido page on there? You're gonna probably have to do it either on another window possibly, or on another device if you have a phone or something like that. Probably is a little bit more convenient. I'm running two computers here, so once you're up there, I can go ahead and give you the opportunity to answer this question on that app. I'm going to go ahead and activate that. It's a poll at this point. Once I activate that, you should get a window should pop up, and it'll just give you an opportunity to answer A, B, or C on pre-course pretest question 1. So here we go. We'll see how that works. Let me know if that pops up on your screen as an option. Okay, great. So if you just select A, B, or C, what you think is an altimeter measures. I have one answer so far, it looks like. Looks like somebody changed their answer. Is that possible? I don't know. Maybe not. Okay, no, I guess we've got 2. Is there anyone that's unable to get onto that Slido page?
So how do you get onto that?
Okay, so you may have to open it up in that. So you might, if you're just doing all of this on one computer, you might have to open another window separate from the Zoom page to open up a Slido page. You don't.
I can just do it on my phone. So.
Yeah, you can do it on your phone as well. Yeah, that works. That works as well.
Where is the Slido page?
I think if you go to the group chat, Ethan just posted up a link to that. And all you have to do is click on that, and it'll take you right to the event. And this is new for me too. So Mark and I played with this a little bit the other day, but trying to integrate it with Zoom. Hopefully in the future, they're supposed to have an app that's seamless and fits right in with Zoom, so we can use this in the future as well. Looks like I've got 4 responses so far.
Looks like people are editing them.
Yeah, that's cool. That's fine. Hey, think about it. And this is not, I'm not supposed to ask any trick questions, but this maybe is a little bit of a trick question, but yeah, it's going to help us, let us think about it a little bit. Don't Google the answer, because if Google will give you the wrong answer, or at least not the answer that I was looking for. So I've had 5 responses. Let's see, we've got 1, 2, 3. I've got 6 participants. But I don't know, Vince, are you participating in that as well?
I was opening up Slido, but I wasn't planning to participate. I'm just listening in and
that's
learning.
cool. Okay, so it looks like we've got everybody's registered an answer there, and I can't see who answered what, but I can see that 33% of the respondents said A, which is probably a good answer. That's an answer that if you Google it, that's what Google will say it. Altimeters for measuring altitude. Obviously, somebody got airspeed, but altimeter, and that would be your airspeed indicator, which is also a pressure instrument. So that's something to consider. And then it looks like we have 50%. So the majority said air pressure, and that's really true. The altimeter is measuring air pressure, and then from that, it determines your altitude, or you have an indicated altitude on the altimeter. So it's really sampling air pressure, and that's what I wanted to get across, that the altimeter is not measuring altitude, it is measuring air pressure. And that is where you will get errors in the altimeter, and that's important for you to know then. So there's different types of altitude, but that altimeter, all it knows is what is the air pressure outside of the aircraft. So I'm going to go to the next pre-test question here. Let's see. So the next one is, which statement is true? And I'll go ahead and activate that question. So you should see pretest question 2 pop up on your Slido app now, and you can select A, B, or C. So which statement is true? And this is regarding the atmosphere. Pressure increases with altitude and temperature decreases. Pressure and temperature both increase with altitude. That's B. Or C, pressure and temperature both decrease with altitude. So as you are increasing in altitude, what is the pressure and temperature relationship, and how does that follow as you are increasing your altitude? Looks like we've got 4 answers so far, and everybody's answered C, which is good. That's good. And I don't know if we're going to get the fifth one in yet, but that's good. So yes, pressure and temperature both decrease with altitude. If you think about when you went up on the jet up to 30,000 feet, it's really cold out there. Obviously, you see that, and only clouds or only moisture out there is frozen. And then the pressure is also decreases, and we'll go into that, and I'll tell you why that's true. Illustrate that as well. All right, so this is our. This is where I identify what the pressure instruments are. And there are typically 3 pressure instruments in a glider or an airplane. They all have altimeters, and the altimeter gives you altitude. Remember, it's measuring pressure, but from that pressure, it's giving you an altitude value, and it tells you how high we are. Right. So how high are we? We want to reference the altimeter to know how high we are. It's especially important in a glider to know how high you are, because that's the only energy that you really have in a glider. You don't have an engine to go higher. The only way that you have an energy to go anywhere is with that altitude. And to determine how far you can go, you need to know what the altitude is. That's fuel in the tank in a glider is altitude. Next up on pressure instruments is the airspeed indicator, which tells us how fast we are going. And airspeed indicators, we'll go in a little bit more depth in that, but they are important. Notice the altimeter is important because it tells us how far we can go within a glider. Also, it tells you, can we clear any terrain that we need to. But airspeed indicator is important to know how fast you're going, because you need to have your airspeed. Anybody who's flown already knows how important it is to have your approach speed correct. If you're flying too fast, you're going to float. You'll use a lot more runway. If you're going too slow, the glider could stall. Very, very important instrument. Many gliders, that is a no-go. If the airspeed indicator does not work, you cannot fly it. You can fly without altimeter, but you very seldom will you have an aircraft like this that you can fly without an operational airspeed indicator. The next step is a vertical speed, and that tells you how fast you're going, climbing or descending. And that's typically found in powered aircraft. You very seldom ever see a vertical speed indicator in a glider. Instead of vertical speed indicator, what we have in gliders is a variometer. And we're not going to go into great detail about a variometer in this course. That's going to be a separate lesson. Variometers are really important in gliders. We need to know how they work and how we'll use them. But they take the place of, oops, back there. They take the place of a vertical speed indicator in a glider. So these pressure instruments measure, what do they measure? They measure pressure, two types of pressure, static pressure, and that's the pressure of the atmosphere. As you're going up through the atmosphere, the pressure decreases, and that's how we determine the altitude. The pressure, the static pressure also helps you determine how fast you're going up and down in the atmosphere. That's for the variometer or the vertical speed indicator. And then the other type of pressure that is measured in a pitot-static system is impact air pressure, and that's the pitot tube. The pitot tube sticking forward out of the aircraft, and oncoming air impacts that, and as you're going faster, then it impacts it more, and that pressure increases. So those are the types of pressure that are measured in a pitot-static system. Does anybody have any questions? We have the chat here. If anybody has a question, go ahead and pop right in there. I'd be happy to answer. If you have any questions about this, we're going to go into great detail, or considerable detail.
Hey, Steve.
Yes.
So a question, is atmospheric pressure the same as barometric pressure?
Yes. Yep. That's pretty much, that's true. That's true. And I think we look at it as atmospheric pressure in an aircraft because you are looking at it as you're moving through the air mass, where typically barometric pressure, you're just thinking about it like most of us, on the ground. What's the barometric pressure at this point on the ground? But yes, it is the same thing. All right, so this is a diagram of a typical pressure instrument system with the basic instruments, the altimeter, the vertical velocity, which is nice here, but that's the vertical speed, or your variometer also references the static air pressure outside the glider in a different way than a vertical speed sensor or speed, a VSI vertical speed indicator does, but this same thing. It references the static air pressure. These, if you look over here on the side, let's see if I can have a little highlighter here so I can point around. These are their static ports. It shows two here. There's not always two on an aircraft. Sometimes there's only one, but a lot of times there are two. And the altimeter, the vertical speed, and the airspeed indicator all reference static pressure. They all need that static pressure to work properly. Now, the airspeed indicator also requires a second input, and this is the pressure system from the pitot tube. The pitot tube faces forward. If you look at the K-21, I don't know how many people have flown so far. I think pretty much everybody. At the very nose, there's that tube sticking forward. That is the pitot tube, and that is where it collects its incoming pressure to determine airspeed for the airspeed indicator. The thing you need to know when you go to answer questions is that if something happens with the static system, it's going to affect all of these instruments. If something happens with the pitot tube, it's only going to affect the airspeed indicator. So that's something to remember. We'll skip forward here, next frame. All right, so this illustrates the atmosphere. Down here at the bottom, this would be at the ground, sea level. And all the way up top here is 164,000 feet. That's rarefied air. That's way up in the atmosphere. One thing we as humans, we don't think of air as having weight or mass. We're born and live most of our lives near sea level here. And when we think of air, we think of nothing, but that is not true. Air weighs 0.08 pounds per cubic foot. So it's a normal bedroom. There is 50 pounds of air in a bedroom. You don't know it, you don't feel it, because we are used to that. Much like a fish at the bottom of the ocean doesn't probably perceive that the water exists. It's always been there. They don't really think about it. You can't see it, but it's certainly there. Now, where air pressure and the mass of the air becomes evident to us is when we have motion or movement, and movement is involved in that. Like if you're going down the road and you roll down the window in the car and you stick your hand out, and now you're feeling the mass, you're feeling that air. So now we can feel it. Still can't see it, but we can feel it. And that's the same thing when the wind's blowing, then the mass of the atmosphere becomes evident. Any questions so far? Anybody have anything they want to ask there? Okay, so what we see is that in the atmosphere, it goes all the way up to some 164,000 feet. You're going to at some point you're going to be into space, but the weight of the atmosphere is much more. That pressure, what barometric pressure, atmospheric pressure, is the highest down here because we have all of this mass of air, this column of air weighing down on us, and that's why the pressure is highest here. Now, as we move up through the atmosphere, you can see that there's less air mass. There are fewer air molecules above us, so that weight is less, that pressure is less, and as we go further up, less pressure. So that's why, and this is the principle that the altimeter works on, is sensing the difference in air pressure and inferring from that pressure or lack of pressure as you go up, what altitude you are at. That clear for everybody? Any questions about that? Okay, next up, next question, next one. Okay, so here we go. This is kind of similar illustration, but this adds a few things that you as pilots are going to have to remember. I don't know, is there an option for you to raise your hands in Zoom? It seems like there is.
Yeah, there is.
Okay, so I'm going to have everybody raise their hands here. I'm going to ask a couple questions and yeah, let's go ahead and let's make sure everybody has that capability. Everybody has identified how to do it. So let's just put everybody as a see Fox, Vinny.
See it.
Mm-hmm. Oh, I think maybe multiple people can't do it at once. But if anyone is unable to find the place where you raise your hand, please let me know.
If you go to participants at the bottom of participants, it says invite, mute me, and raise hand.
Beautiful, beautiful. Okay, so these are items. Was everyone able to read the little homework assignment that we had? I think it was about 11 pages in the glider flying handbook.
Yeah.
Okay. So good, that's great. What I wanted to point out is there are a few items as a pilot you're going to have to commit to memory, and this is one of them. So hate to tell you they have to memorize things. I hate memorizing things as well, but this is important, and it's something you're definitely going to need to know this information to pass your FAA written exam. And you will refer back to it as you get your private pilot's license, your multi-engine rating, your IFR rating, any advanced ratings that you have. This is information you're going to have to know. And I'm not going to tell you that you need to know how many hectopascals there are. You need to have one of these two pieces of information. So I'm going to go through these real quick, and we'll go over them. So what you need to know is the standard atmosphere at sea level. That is what is considered a standard day. So they, to determine this, they kind of figured out what the average is. So at sea level, on a standard average day, the pressure is 29.92 inches of mercury. That's what HG is, 29.92 inches of mercury. This is probably what you're going to want to use, because in the United States, this is what we use on our altimeter. And those of you who have been in the glider and have worked with Mark or myself, and you're setting the altimeter to field elevation, you'll see in the Colesman window, these are the numbers you're working with, inches of mercury. So on a standard day at sea level, 29.92 is the standard. Now, at that also, temperature is important as well. So temperature is related to all of this, the atmosphere and pressure. You need to know what the standard temperature is, and that is 59 degrees Fahrenheit or 15 degrees Celsius. I would suggest that you commit 29.92 to memory, and then 59 Fahrenheit, 15 Celsius. That you need to remember. Those are things you're going to refer back to in the future flying. The other thing that you should commit to memory is a standard lapse rate. And I'm going to tell you what a lapse rate is. This is important for making calculations. You'll have to make these calculations as you're going through ground school or answering questions on a FAA written exam, or in a practical manner, or calculating what cloud heights might be, or what aircraft performance would be at different elevations. So the standard lapse rate is 1 inch of mercury per 1,000 feet. So let's say we are on a standard day and we are at sea level, 0 feet MSL, and it's 29.92. We can infer from that information that 1,000 feet above us, the pressure would be 28.92. It would decrease an inch for each 1,000 feet. Now that's only true up to 10,000 feet. Beyond 10,000 feet, it changes. So it's only valuable up to 10,000 feet, but that's probably where you're going to be using that information most anyway. So 1 degree per 1,000 feet is the decrease standard lapse rate for the atmosphere. The temperature also changes. So here we are at our standard day and it's 15 degrees Celsius. And I like Celsius for this reason because it's real simple to remember that the temperature lapse rate in Celsius is 2 degrees. So for each 1,000 feet you go up, the temperature would drop 2 degrees. So let's say it's 15 degrees Celsius at the surface, and we want to know what the temperature would be 1,000 feet above us. We just subtract 2 from the 15, that makes it 13. So we know 13 degrees at 1,000 feet. At 2,000 feet, it would be 11 degrees. And this is important, especially for gliders, in calculating whether a day is going to be good for lift or not. This is something that the standard lapse rate is something important to know whether a parcel of air is inclined to rise and you're going to experience lift. So these things, I would definitely, if you have a notepad or you want to write these down or just refer to them, maybe you've already memorized them, but these are important items for you to memorize as a pilot, and you're going to end up using them in the future. So one of the things that I wanted to point out as well is on this illustration or this diagram that at sea level on a standard day, the pressure would be 29.92. And we think about that as an altimeter setting. Now let's see, somebody who's been flying a fair amount. How about Jonathan? If you could unmute your mic, I'm going to ask you a question. I'm not going to try to trip you up or anything here, but unmute your mic, I want to ask you. So we know that on a standard day here at sea level, we'd set the altimeter for 2992. That's what we got from the tower. They said that was the altimeter setting. What would you expect? So you had an airport up here at 18,000 feet. There aren't too many there, but at 18,000 feet, and it was a standard day as well. What do you think our altimeter setting would be? Remember, it's a standard day and standard temperature and all that.
Would it be the same?
Good, you are right. It is the same. It's 29.92, even though you're up here, and the pressure is only on a standard day up here. The pressure is only 14.9, but right, the difference between these two is what gives you your 18,000 feet on your altimeter. Very good. Good answer. Good answer. I appreciate you stepping up and answering that for me. Okay, so does anybody have any questions about this? Somebody's got to have a question about this one. Maybe not. Maybe everybody's got a real good handle on the atmosphere, atmospheric lapse rates. And Ethan has his hand up. Is that intentional, Ethan?
You asked us to raise them. So
Oh, well, you can put your hand down now. Okay, all right. I just want to make sure you were able to. Good. You got me. You got the instructor. All right. So next frame. All right. So this illustration, this diagram shows a glider similar to a K-21, and the location of the pitot tube. It's right up front there, and you can see that onrushing air. You know, that's what that's measuring, is the pressure up front there, and the pressure increases as you're going faster. Back here in the back of the glider is where the static ports are located. I believe they're on the side of the fuselage. I was going to have somebody go look, but and on our, I think in the center is where our total energy probe that would power our variometer. But these are the important ones to know right now. Pitot tube facing forward. On some, they're out on the wing facing forward. It's typically that pitot tube wants to be out in undisturbed air. You don't want it real close to the fuselage or anything where the interference air pressure could alter that measurement, because you want that to be relatively, you know, you want it to be as accurate as possible. The static ports are on the side, and if you can imagine, those are not facing forward, so they are not going to get any increased pressure from ram air. That's what that's called, is ram air. Pitot measures ram air pressure. Any questions about that? Okay, so here's the diagram for the altimeter, just broken down by itself. First instrument we're going to really talk about is the altimeter, and this is your altimeter, and it goes out. This is your static system, goes out the static ports. That's all the altimeter it reads, is this pressure, static pressure on the side of the aircraft, and that's how that works. All right, so here is an illustration of here's the face of an altimeter, and so it does say, does anyone have any problems reading an altimeter? We're going to go over that anyways. I just want to see if anybody does. Pipe up and let me know. It's not something that's naturally that you're born with. So here's the face of our altimeter, and here's the adjusting knob. You know, I was talking about the Colesman window. This is where you'd adjust to that altimeter setting, depending on variations in pressure, because pressure does change. It's not always the same. Different weather systems go through, high pressure systems, low pressure systems, and this is where we change that to dial in our altimeter to where it's getting the correct indications. So this is similar to a clock. This, you know, being the hour hand, this is going to measure thousands of feet. This nice kind of thick, short hand. The long hand is hundreds of feet. So this one's kind of like your minute hand on a clock going around. For each time it goes, this one goes around, it's 1,000 feet. This would pop up another 1,000 feet. This real thin, skinny hand here would maybe look like a second hand, but it's not. It's going to move. It's tens of thousands of feet. So this one moves really slowly. So we can see here where this would be 10,000 feet on that hand. We're under that, so we know that we're under 10,000. This is showing, you know, pointing near the 7, but a little short of the 7. So we know we're 6,000 something, and then there's the 900. So 6,900 feet is the indicated altitude on this altimeter. And I'm going to have a couple altimeters will pop up. Okay, the little hand. All right, great. So the little hand I'm sorry, Fox, the thin hand, the little narrow one up here, is that the one you're referring to? If this is the one.
No, the short one.
Oh, the short one. Okay, so that short, fat one is thousands of feet.
Okay,
Thousands.
thanks.
Yep. That's thousands. This is hundreds. Let's see here. Okay, and one other thing to note is that the altimeter, so I'm going to read this real quick for you. The barometric pressure can be changed approximately 10 feet for every 0.01 inches of mercury. So that kind of falls back to what we said. 1.0 is 1,000 feet. 0.01 is 10 feet. All right, so the inside of an altimeter, what does it look like in there? What makes this happen? What we have here, it's cut away, so we're looking inside the altimeter, and here's our needle and our gear. And I think this is definitely oversimplified, but we don't need to know. We're not going to rebuild altimeters in this class. We just want to know how they work. So there's a linkage that drives the needle, and this linkage is attached to an aneroid capsule, a sealed copper and beryllium alloy capsule from which the air has been removed. So they pulled the air out of it. It's got a vacuum in it. It's springy. It's designed to compress as the pressure around it increases and expand as it decreases. So, and then here it shows that this enclosure is all airtight. So the only pressure that's entering or departing from the inside of this altimeter is through the static port. So, and that goes out and plumbed out to your static ports on the outside. Let's see, linkages. Okay, what you can see is that the static pressure, as the pressure, say you're descending, you're going down through the atmosphere, and the atmosphere is getting thicker, the pressure is increasing, you're going down. This pressure increases in here, and it moves this wafer or capsule, however you want to put it, it moves it as the pressure increases. You can see that would move across that way, and then the needle would spin down towards zero. Now, as you're climbing back up through the atmosphere and the pressure is reduced on the static pressure line, this starts to move that way, and so that indicates an increase in the altimeter. Hope I was referring to altimeter throughout this. So yes, static pressure moves back and forth, or increases or decreases depending on whether you're going up or down in the atmosphere, and that's what registers as increase or decrease and shows your altitude. Is there any questions about that? I see one pop up here. What is the triangle touching the 10,000 foot arm? Okay, so that's back here. The triangle, are we, I'm not quite sure. Ethan, can you unmute and maybe help me determine?
The 10,000 foot one, the super skinny one.
Oh, at the very end. Okay, that's just part of the pointer. So that will move along. Or, yeah, so that's just part of it. On this, and many altimeters look differently. Some of them, don't have a 10,000 foot marker. There might be a little window here that rolls over as you go through the 10,000 foot mark and you start counting up again. So this is a generic, but yeah, that's just part of the needle. So it has no other bearing. Any other questions about this? Does anybody have a question about how this pressure increasing or decreasing would make the needle go up or down? Or why the pressure is increasing or decreasing inside it? Any questions about that? Okay. Moving forward. Okay. So here we have some airspeed or altimeters, excuse me. Altimeters. I'm gonna pick on some people to tell me what these altimeters read, so you can start taking a look at it, see what you think they read, and I'll pick some people out to unmute and tell me what they see on these altimeters. But so while they're taking a look at that, so prior to takeoff, the altimeter should be set to the current altimeter setting. You'd get that from a tower or weather report. So, or and those of you who've been at Hood River, there's a frequency there for AWOS, and it will tell you what the current altimeter setting is. You can dial that in right here. Now, you may have noticed we don't really do that with the glider. We know what the altitude is at the field. We know it's 638 feet. We usually dial that in for 600 feet. And so you can also, if you know what elevation you are at on the airport, you can also do it that way. So you could set the pressure in this by from an official source for that time, and your altitude should indicate field elevation, or you can set field elevation, and then from that you can tell what the local altimeter setting is. So it works both ways, either way. So if the altimeter setting is not available, the altimeter should be set to the elevation of the departure airport. One thing to think about there is that airports are not all totally level, so you need to know if you're really looking for a really accurate altitude setting, you need to know what the altitude is on each end of the runway. It might one end of the runway to the other end of the runway might be 30 or 40 feet difference, different points in the airport. Less critical on a glider when you're flying VFR, because you really need to be looking out the window and determining your altitude by visually assessing it and understanding it. So, and then we went over this before, but rotating the setting knob on the altimeter simultaneously rotates the setting dial and the altimeter hands at a rate of 1 inch per 1,000 feet. We talked about that. That's the standard lapse rate up to 10,000 feet, right? So that's easy to remember. It's duplicated here. So it says here, thus increasing the setting dial from 29.15 to 29.85. So you're increasing it. 85 point minus 15 is 0.7. So you're increasing the altimeter setting 700 feet. Any questions about that? Okay, so let's see here. How about Vinny? Why don't you tell me what the altimeter 1 says, if you can read it. If not, if you have any questions,
500 feet.
500 feet. Yep, that's right. So this is the hundreds. It's at the 5, and here's the thousands. It's halfway between the 1 and the 0. It's 500 feet. All right. How about, let's see here. Kieran? If you want to unmute, could you tell me what altimeter 2 says?
Like, let's go.
Um,
I just hand over all of them.
is
Let me
it
just rub my hand over.
five?
All right, but that's gonna be your last one, Ronan. Because
Looks- sounds like you got some-
brownies.
Sounds like you got some background noise there. That's okay.
Yeah.
If you if you want to go ahead and just, can you put that in the chat window? Go
Yeah.
ahead and put that in the chat window and all, or your best guess. Okay, all right, so it's a pretty good guess. However, it isn't. It's one. Let's see this. Let's go back here a little bit. This hand here is the thousands, right? So halfway between the 1 and the 2, here, this would be 1,000. This would be 2,000, right? There you go. You got 1,500. That's right. Yep, perfect. Okay, so that's 1,500, and let's see here. How about Fox? Why don't you go ahead and take this one on number 3 for me?
I think it's like I think it's about 100,000. Wait, no, sorry.
That's all right. That's all right. And it doesn't, I'm not asking for to the feet, you know, if you're close. And we can talk through it here. So this hand here, this thick hand pointing up here, that's the thousands, right? So it's between, this is between the 9 and the 0. It's probably one of the more challenging ones. This would be 9,000 feet. This would be 10,000 feet here. You can also see this is the 10,000 marker, just short of 10,000 feet. And then this is the hundreds here. And it's pointing to 500. So you're 9,000. You always look at the thousands first and then look for the hundreds next. So 9,000.
Oh, so it's 9,500 and
Yeah, 9,500. And so this is, yeah, so that's it really. There's no tens of feet here. So this would be, it shows it's just, you're just short of 10,000 feet. If this one, if you went up another 500 feet, this would wind up here to the 0. That would be, so that one and these would both be pointing out, and that would be right at the 1. Then you'd be at 10,000 feet. But you're just 500 feet short of 10,000. Does that make sense?
Yeah.
Okay, cool, good. All right, and this is something that with practice, you know, you'll just glance at it and you'll know it. But it takes a little while to get your head wrapped around it. So definitely, this is why we're having class. Figure these things out. All right, does anybody have any other questions about what these altimeters are reading, or any confusion about what they're reading, or anything here that we've followed so far? The black and white stripes. Black and white stripes down here at the bottom. You know what? I don't know what those mean. I'm not sure what those are, but we can find it out. We can look it up. I will look that up because I want to tell you that preparing this class, I've learned a few things that I didn't know or didn't know very well. So this is a learning experience for all of us. And as you progress through your aviation career, you're going to be constantly learning. That's one of the that's really the really cool things about flying for me. I love learning new things, and I like things that are a little bit complicated. So we're all going to be learning in this ground school course, including your instructor. And one thing I've learned is that I'm not going to try to tell you that I know something I don't know. I'm going to admit it. I just don't know. So I'll look that up. I'll get back to you. It was Vince that asked that. All right. So, okay. Let's see. We're going to move up. next frame here. I can get it to move. Okay, so different types of altitude. When we put this ground school together, there was some question. People were interested to know what different acronyms meant in aviation, and that's something that we, as you know, have been flying for a long time and have picked up on a lot of this stuff. And you learn it as you go. You don't really think about it too much. And then somebody who's just coming into it, they're overwhelmed by all of these terms and acronyms and whatnot. So we're going to try to make a real concerted effort to focus on terms and acronyms and associated with aviation. So these are items that you're going to want to commit to memory as well. So these are different types of altitude, and indicated altitude is the altitude you read off the altimeter. You look at the altimeter and that number on the altimeter, that's indicated altitude. You may be asked flying along air traffic control or a tower, or somebody might say, what is your altitude? And you're going to report back your indicated altitude. That's what you're going to tell them. Next up is absolute altitude. Absolute altitude is your height above the surface, above the terrain. So if you show on your altimeter that you're at 10,000 feet, but you're over Hood River, which is 600 feet, then your absolute altitude is 9,400 feet. That's your altitude above the ground. That obviously changes as you're flying along. You fly over a mountain, that can change dramatically as you're flying along. The altimeter does not tell you how far you are above the surface. It tells you how far you are above sea level when the altimeter is set with the correct altimeter setting. So absolute altitude is the altitude above the surface. And then there's true altitude. True altitude is the true height above sea level. That's what we see as mean sea level. You'll see this MSL. That means that's mean sea level. That's like an average of sea level. People talk about sea level like it's one figure, but really different oceans are different levels and different places on the ocean, depending on the tide. The seas are at different levels in different places, but the mean sea level is an average of those that we've established as sea level. And then we measure all elevations on a map, on a chart, based on what that mean sea level is. And that's what you see on charts and airport diagrams is true altitude. That's the height above sea level. Now there's two more types of altitude. One is pressure altitude. Pressure altitude is the height above a standard datum plane. It's an imaginary, maybe imaginary isn't a good term, but it is a theoretical place that we have determined is the standard temperature is what we talked about, 15 degrees Celsius or 59 degrees Fahrenheit, and the standard pressure is 29.92 inches of mercury. And pressure altitude is not something you would ever report to someone at air traffic control. If you're talking to somebody, they're never going to ask you what pressure altitude is or density altitude. These two types of altitude are only used for calculating performance of the aircraft. So when you are planning your takeoff or you're going to land at an airport and you need to find out how much runway you're going to use or how fast the airplane or glider would climb, that's where you will use pressure altitude and density altitude. They're used, and see down here, pressure altitude is used for calculating density altitude. Density altitude is used for performance calculations. So this is all these are ever used for is figuring out performance of the aircraft that you are flying. And I've got some additional slides here that hopefully will kind of illustrate this a little better for you. Does anybody have any questions so far? Please let me know if you do. Okay, so here's our airplane flying along and it's absolute altitude. Once again, absolute altitude is your altitude above the terrain. Then your true altitude is your altitude above sea level. And your pressure altitude is your altitude above this standard datum plane. And the reason this is important is that we need to have a basis for making those performance calculations. And that's where manufacturers and engineers, they use this standard datum plane as a benchmark to determine the performance of the airplane. You're flying along and you're actually flying, these are the important ones, true altitude, which is expressed as MSL, mean sea level, altitude above sea level. And that's what you will have on your altimeter if you have it set to the correct altimeter setting, which you would get from weather reports. Absolute altitude, once again, that's not shown on the altimeter. Altimeter does not know how high you are above terrain. There are other instruments that may tell you how high you are above terrain. Usually those are going to involve radar. They might involve GPS, because the GPS can determine your altitude, and it can also determine what the altitude or the elevation of the terrain below you is. It could possibly give you an absolute altitude indication, but the altimeter is never going to tell you what your height above terrain is. That's something you've got to work out based on your charts and knowing how high the terrain is, and then how high you are flying. Any questions about that? All right. I must be a great teacher, no questions. So let's see here. So the last thing that we need to discuss that's going to be important for you to know when you are going through your practical test, and there are some questions that ask you this. Fortunately, there are none that require you to do any math or show you what, come up with an absolute number, but they are going to ask you to understand the concept. So this is the concept. When I first started learning to fly and taking ground school a long time ago, I remember this one, and it still sticks in my mind, and that is a rhyme that pilots use to remember something important. And that is, from high to low, look out below. From low to high, you're in the sky. It's pretty easy to remember a little rhyme that helps us remember this principle. And sometimes it can be a little difficult to wrap your head around. So I'm not going to get into great detail about it, but I'm going to try to give you the best information I can. So when you're flying between areas of non-standard pressure, so we know that 29.92 is standard pressure, but that doesn't exist, and especially when you're looking at across a wide area. So if you're flying a long distance, or if you're in the air for quite a while, if you're in a glider and you fly for 3 or 4 hours on the ridge, that pressure could change as you're coming back. Now, fortunately, we can adjust that pressure. We can call in, or we can dial up on the radio and find out what the AWOS says the pressure is, and we can change that, and we can get our altimeter corrected as that pressure is changing. But there may be situations where you're flying from one place to another and you don't have pressure information. But you do know roughly that, hey, I'm flying from a high pressure system to a low pressure system to a high pressure system. I'm flying from someplace where it's very cold. So I'm here in Prudhoe Bay and it gets to be 50 below zero. And if I fly 600 miles south to Anchorage, it might be 30 degrees above. So I'm flying from one extreme to more of a standard temperature. These are situations where, it's good to know, and you were going to be asked some questions on the practical exam about this. So if a flight is made from an area of high pressure or high temperature to an area of low temperature or low pressure without adjusting the altimeter setting. So this is assuming, as far as the pressure is concerned, we're not adjusting the altimeter. We aren't able to. So if you're flying from an area of high pressure, high temperature to an area of low temperature or low pressure without adjusting the altimeter setting, the altimeter will indicate higher than the actual altitude. So if your altimeter is showing that you're higher than you actually are, that's not good. That's bad, because you could be lower, and you say that you've got to fly over a mountain range that's at 10,000 feet, and your altimeter says you're at 11,000 feet. We're all good, but actually you're not at 11,000 feet. Your altimeter says you're at 11, but remember, it's indicating high. Now you may not clear that mountain range. Less and less critical in a glider there again, because we're flying VFR and we see the obstacles below us. But as you go along in your flying career and your flying instruments and you can't see, with the terrain around you, then it's very important. So from high to low, look out below. The second part of this is a flight is being made from an area of low pressure or low temperature to an area of high temperature or high pressure without adjusting altimeter setting. The altimeter will indicate lower. So it's telling you you're lower than you actually are. This is less of a problem because you're higher. The higher you are, more altitude is actually better because it's keeping you away from that terrain, and that's why you have this sing-song, low to high, you're in the sky. That's great. Another way of looking at this, it might be another way of another saying, another thing to remember, alternatively to this, is that in higher temperatures, you are higher than the altimeter reads. In lower temperatures, you are lower than the altimeter reads. And this is really probably the crux of the whole thing here, because typically you're going to be setting the altimeter to the correct pressure. But where you don't have any correction on the altimeter for temperature, there's no dial to change for temperature changes. And the altimeter is designed and manufactured to work at standard temperatures. And when the temperatures are not standard, that's where you run into a problem. So in higher temperatures, you're higher than the altimeter reads. In lower temperatures, you're lower than the altimeter reads. And I've got a couple illustrations here that kind of line this out to illustrate a little bit better. Let's see here. So here is, this is 15 degrees Celsius, 59 degrees Fahrenheit. Let's see, how about Vinny, unmute your mic here real quick. I got a question for you. You with me?
Yeah, sorry, I just got a movie in the background.
Okay, great, cool. Okay, so, all right. So Vinny, right here in the middle of this little illustration, see we have over here, it's 30 degrees Celsius, which is 86 degrees Fahrenheit. That's pretty hot. And down here on the other end, we've got 0 degrees Celsius or 32 degrees Fahrenheit. That's the freezing level. That's pretty cold. What about this one here? This one, what are you reading here for temperatures? Right down to bottom.
What am I reading for temperature? Or
right, it's right on there. It's 15
degrees Celsius and 59 degrees Fahrenheit.
Okay, all right. And we just talked about that here a little earlier. I said we needed to commit that to memory. What is that temperature? I mean, what can you tell me about that temperature?
That's standard temperature?
Bingo, that's right. That is a standard temperature. That's a standard temperature. And then at standard temperatures, that your altitude, there's no variation. So the true altitude, your indicated altitude and true altitude are correct. So if your altimeter is reading, here's 5,000 feet, your altimeter is reading 5,000 feet, you are at 5,000 feet when the temperature is standard. Does it make sense?
Yep, makes sense.
Okay, all right. All we're talking about right now is just variations as far as the temperature, because that's what we're talking about is high to low, look out below. We're looking at that as a perspective. So at standard temperatures, it's right. Now look back here. Here it's much hotter. It's warmer. Warm air expands. It's expanding. It's spreading out. And what you see is that these pressure levels are also spreading out, right? So back here, we're showing we're at 500-foot pressure level. So the altimeter sees a pressure that it interprets as being 5,000 feet, right? But we're not at 5,000 feet. We're well above it. We're up here. Maybe it's, I don't know, 6,000 feet. So colder, higher temperatures, you're higher than your altimeter is indicating. Low to high, you're in the sky, you're high. Where you're really running into problems is on this end, right? We're going colder. This is cold. Cold air contracts, cold air shrinks. It's all getting close together. All those molecules are huddling together, right? And it's contracting. And you see this is all of these pressure levels have contracted together. They're gotten closer together. And this is that level that the altimeter thinks is 5,000 feet. This is a pressure that the altimeter interprets as being 5,000 feet, but you know you're lower. This is 5,000 feet up here. So maybe you're down at 4,000 feet. One thing I want to say about this chart is it's not representative. I mean, it's not true to scale. You couldn't interpolate from this as to what the difference is as far as altitude. You really you'd have to run some calculations. There's formulas. The Airman's Information Manual, AIM. I don't know if you guys are familiar with that, but that's there's FARs, which are the regulations that have to do with flying. And in that same book, you have the AIM, Airman's Information Manual. In that there is a chart that you can use for calculating the difference. And it's only shown for cold temperatures because that's where it's most critical, right? You're too low, you're lower than what you think you are. And that's where you could run into a real concern. And I do have that chart here. We can pop it up. I believe it's the next frame. Okay, well, here's another one that kind of also illustrates it. Your reported altitude. So let's say this is 5,000 feet here. If you're in higher temperatures, you're actually up here. You're higher than what your altimeter says, which is less of an issue than it is when you get to a cold temperature and you're below what your altimeter indicates. So what we've discussed here are ways that the altimeter could be inaccurate, which is important for you to understand those ways that an altimeter might not be telling you what you think it's telling you. Flip through. Center of the page, this shows that table where you can determine the difference, the error based on temperatures. I'm not going to go into a lot of detail on this. This is something I just learned a lot more about trying to represent, because I had some real questions about this. I'm not going to, and you're not going to have to reference any of this when you do your private pilot glider written exam, but this is where that information comes from. And here, a temperature of -10 degrees Celsius, and the aircraft altitude is 1,000 feet. So we have -10 right here in this column, and the aircraft altitude is at 1,000 feet here. We can see that your altimeter is showing 1,000, that's your indicated altitude, but the error is 100 feet below that. So the altimeter setting may place the aircraft as much as 100 feet below the altitude indicated. So that's the scale of error that we're talking about with this. Maybe not a deal breaker. Closer to the ground, it's less of an issue. At higher altitudes, it's more pronounced, but you do need to know that high to low, look out below, low to high, you're in the sky. That is something, commit that to memory. You're going to need that to answer some questions on that written exam. And I think that pretty much covers altimeters. So how is everyone doing so far? Looks like we've been at it for 1 hour and 5 minutes. Do you guys want to take a break? Continue on? I'll tell you what, let's take just a second here. And what I'd like to do is have everybody kind of take a chance, take a moment. And what I'd like to know, we are all interested in aviation, we're all interested in flying, obviously, we wouldn't be here. But I think we all have other interests as well. And so what I'd like each person to do, let's start with Vinny. But first off, flying is something I'm interested in. But another thing I'm interested in is high performance cars and sports cars, and that's something that I do as well. I've got too many sports cars. I need to sell a couple and buy an airplane, but that's one thing that I'm interested in besides flying. And how about Vinny? Why don't you tell me something you're interested in besides flying?
I'm very much interested in rocketry. Yeah.
I'm sorry, I didn't quite catch that.
Rocketry.
Oh, rocketry. Okay, all right. So I did a lot of that when I was a kid. I built a lot of those solid rocket, like Estes motors rockets. Is that what you're talking about?
Yeah, but I'd love to look into the higher level stuff. That's my favorite thing to research.
So what kind of propulsion are you talking about?
I like learning about like higher level rockets, other than like a liquid fueled engine.
Okay, all right. Wow, cool. Very interesting. That's cool. All right. So how about Vince? I'm gonna get you in on this too.
Oh, I didn't know I was going to get called on.
Sorry.
Yep. No, I'm a photographer by trade, so that's one of my lifelong interests. I really enjoy photography and capturing things that I see around me that are interesting and beautiful. I do a lot of outdoor activities: hiking, backpacking, mountain biking, snowboarding, that kind of stuff. Usual Northwest stuff. So
Great, that's really cool.
Yeah.
I had a dream to be a photographer as well, and I told my parents that I wanted to go to Hawaii and be a photographer, and they said, "Nope."
Yeah. Nice.
Yeah. All right. So let's see. How about Jonathan? I know a few of your hobbies as well, but I'm gonna let
Yeah,
you
I like
tell everybody.
hunting, fishing,
Mhm.
dirt bikes, stuff like that.
So you, I think you were talking about going hunting for elk when I talked to you last. Did you ever go do that?
Yeah, we didn't get anything this year, but yeah, I did go hunting.
So is that something you're interested in using an airplane for?
Maybe like flying back into Alaska or something.
Yep, it's a great way. It's a great way to see the state of Alaska. You can't really see it any other way. So yeah, I definitely suggest flying. And Alaska is a beautiful place to do it. So let's see. How about Fox?
I'm kind of into mountain biking and rock hounding.
Oh, cool. So in rock hounding, are you like, I mean, geology, the geological aspects of rocks, or like?
Well, like, since a lot of Oregon has like the desert and where there was lots of volcanic activity, there's a lot of like really amazing rocks out there. So I'm more into finding and collecting rocks.
Cool. Now I am listening to a book right now that you might be interested in. It's kind of a geeky book, but it talks about how the Earth and the whole solar system was formed, and it's all from a geologist and a mineralogist's point of perspective. It's very interesting. It's called The Story of the Earth, the Story of Earth by Robert Hazen. So something I listen to audiobooks a lot, and that's something that it's really quite interesting of how the Earth formed and minerals and rocks and how that all fell into the development of the Earth as a living planet. It's very interesting. So if you're interested in it, email me and I'll send you a link to it, share it with you.
Cool.
All right. So let's see. How about Ethan?
I like robotics and programming and stuff.
Oh, that's really cool. So do you do anything like with drones or anything like that?
Not really.
Yeah, I just recently I've started playing with drones and the controlling of course, robotics. And robotics, you are controlling the robot. You're not like imparting any artificial intelligence to it. I guess I'm probably displaying my ignorance as far as that goes, but you're directly controlling it.
That or giving it a specific set of commands to do, and then
Okay, all right. Okay, all right. So there is some aspects of drones that are that way too. So you have a flight controller, and it will stabilize itself. So there's I could see some parallels between that. It's not something that I don't have a lot of time anymore for that, but that's very interesting. So what your robots what do they do? What do you program it to do?
well, I did an FTC last year, which is basically you build robots to do challenges and you compete against other teams.
Oh, I see. Okay. So what was the challenge? I mean, can you, in a nutshell?
There's like a group of challenges ranging from like move something there or stacking Lego-esque blocks.
Oh, I see. I see. Interesting.
And then there's like different time spans of like 30 seconds of autonomous programming being done, and then like a minute and 30 seconds of somebody actually driving the robot.
So do you get this challenge at the competition and then you program it right there to do what the challenge is?
No, you're like told about the challenge in advance.
Okay. All right. I was going to say that
You
sounds
get multiple months. Every team
Okay,
gets
all right.
multiple months to prepare.
I got you. Cool. Very interesting. All right. So let's see. Kieran? Is it Kieran?
Yeah. Okay. It was also photographer.
Oh, photographer?
Yeah.
Okay. Well, it sounds like you got a busy house there. I hope you're picking up on something from the class.
Yeah.
So, I mean, do you feel like you're getting some value? Are you learning anything from this class, or did you?
Yeah.
Did you have a chance to go through the homework assignment ahead of time?
Yeah.
Okay, great. Okay, cool. All right. Let's see. Did I get everybody? I think I got everybody. If I missed somebody, let me know. I think we got everything. Okay, cool. All right, so we're going to go through this, and I'm going to try not to talk too much, but I'm going to try to get the information to you in a efficient manner, and hopefully you'll learn something. Is everybody doing okay? I mean, any problems? I mean, we could carry this on another night if we're running out of. If you guys are running late, we are kind of running on, and we might have to continue on, or we can do the questions, run through those real quick, and see how we do on those, or at least some of them. So, not hearing any objections.
Yeah, question sounds great.
Okay, all right. Well, let's. What we have here next is airspeed indicator, and that was the second instrument that we needed to talk about. We've covered the altimeter. So here's a diagram of the system for an airspeed indicator, and we've kind of gone over this again. So I'm just going to go quickly over it. Pitot tube up front, airspeed indicator. We've got our static pressure line going towards the back, and let's skip forward real quick. Go ahead and go into that. So, all right. So here is an airspeed indicator. This is your airspeed indicator. What we have is a color-coded arcs here. So this is not necessarily representative of the glider, the airspeed indicator you're going to see on the glider you're flying, but it is the airspeed indicator that you're going to have to answer questions on in the private pilot exam. And I've tried to narrow this down to things that are also pertain to gliders. So this white arc here is, let's go with the first. The first one up is green arc. The green arc is the normal operating range for your aircraft. In this speed range, you are pretty much free to fly the airplane in this green range at any time, and regardless of what the atmospheric conditions are, if there's turbulence or something like that, this is your free range. This is your normal operating range. Might remember that. NO, normal operating range. So that's your green arc. The white arc is the operating range with flaps deployed. Typically, you're going to put flaps down to land so you get a slower stall speed. The bottom of that white arc is going to be the stall speed with the flaps deployed when you're landing. And the top here of the white arc, you wouldn't want to fly with those flaps out faster than this. You could cause damage to the flaps. So that's the maximum speed with flaps deployed. That's just a flap operating range. Yellow arc. The yellow arc at the top of the airspeed indicator is your caution range. You can fly airplane or glider in the yellow caution range, but you do need to be cautious. Kind of like when you see a caution sign on a highway going around a corner. You could go faster. The speed limit is what the speed limit is, but they tell you a cautionary speed. You probably don't want to slow down to 35 going around that corner. And you're in a sports car or on a motorcycle, you might be able to do it at 65, but without breaking the law. But this is caution range. You want to use caution. And what caution is that? You only want to fly in that range when you have smooth air, right? So when it's smooth air outside, nice calm day, you can fly in the caution range without much concern. The reason that it's dangerous to fly in that caution range when it's bumpy is that you can enact forces, or kind of like going over a bumpy road very fast. You could damage the aircraft flying at that fast of a speed over bumpy air, through bumpy air. And then up here at the top is the red line. That should be pretty much self-explanatory. That is VNE, which is velocity to never exceed. You should never fly beyond that red radial line. That is, they've designed the aircraft to fly and be safe up to that point, but beyond that, you are a test pilot and you don't want to fly a glider or an airplane. Beyond the red radial line, you could have disastrous results. So that's what the red radial line, those are the markings on this altimeter. And then there's airspeeds that you need to know. Let's see here. How about Jonathan? Would you unmute? I'm going to ask you a question. Okay. And Vinny, I'm going to catch you next after Jonathan here, and we're going to try to go through these real quick. So, Jonathan, this first one here is VSO. Why don't you read that to me?
Stall speed or minimum steady flight speed in the landing configurations, the lower limit of the white arc.
Right. So that's right here, right?
Yeah.
Okay. Now, how about this next one? This is VFE. And a lot of these are really nice because the VSO doesn't make much sense, but VFE kind of does, because it's flap extension speed. So why don't you read that one and then tell me where that one's at.
Maximum flap extended speed, the upper limit of the white arc, the entire white arc defines the flap operating range.
Yep, that's right. That's right up here. Right up here. On this one, it's at 100. Okay, cool. Excellent. I'm going to have you answer this one too, the VS1.
The stall speed or minimum steady flight speed in the specific configuration below the limit of the green arc. The entire green arc defines the normal operating range.
Okay, right. Yep. So this is VNO. NO is normal operating. And VS1, that's stalling speed with your flaps retracted. That's at the very bottom of the green arc. Thank you very much, Jonathan. I appreciate that. All right. So, Vinny, let you pick up a couple of these real quick.
Which one?
Let's see. What do we do? I think we finished up with VS1. Yeah, so you're going to VNO.
The maximum structural cruising speed, the yellow arc. The yellow arc defines the caution range, which should be avoided unless in smooth air.
Okay, yeah, that's VNE, right? Oh, is that? Oh no, yeah, right, VNO. Okay, so maximum structural cruising speed, upper limit of the green arc. Yep. So that's up here. All right, and VNE.
VNE never exceed speed, marked in red. There are other important airspeed limitations that are not color coded on the airspeed indicator. VLE, the maximum landing gear extended speed, and VA, the design manufacturing speed, which may result in rough air and severe turbulence is encountered. Airspeed should be reduced to maneuvering speed unless to minimize stress on the airplane or the airplane structure.
So how about VA? Can you find VA on this airspeed indicator and know where that's at? Okay, I'm going to hold you up there. So you're not supposed, I mean, as an instructor, I'm not supposed to ask any trick questions. VA is an airspeed that's never shown on an airspeed indicator because it changes. VA changes depending on the way the aircraft is loaded. So that's something you have to calculate. A heavier aircraft, believe it or not, when it's heavier, your VA speed, your design maneuvering speed is higher. And when it's light, more light loaded, you can't fly as fast. And once we get into some aerodynamics, we'll go into that in detail so you'll understand why that is true. But VA is not depicted on the airspeed indicator. And a VLE landing gear, maximum landing gear extended speed, that's also not shown on this. VLE might be important in a glider because some of them do have retractable gear. Whether or not they have a maximum landing gear extended speed or not, I'm not sure. Okay, thank you very much, Vinny. All right, so those are your V speeds. And if anybody would like to get a copy of this this PowerPoint, so they have that, I can send them to you. If you just email me, I'll send you this, and you'll have all these slides, and you might use these. All of this was pretty much picked up from the Glider Flying Handbook, so you can also find it in there. You may notice some of that. I plagiarized it, but it's the FAA, so it belongs to all the taxpayers. All right. Okay, so here is an airspeed indicator, similar to the picture that we saw previously of a altimeter. Only thing is, on an airspeed indicator, remember we have two pressures that we are comparing. You are comparing your total pitot pressure. This is the ram air from the pitot tube going in from this side, and then it's balanced against the static air pressure. Static air pressure, it changes as you go up and down, and also this pitot pressure will change based on altitude. That's why it's important for this to reference the static pressure at the static port as well to determine what your airspeed is. Here's our needle gear, very similar to how the altimeter is set up and linkages or whatnot. And then the diaphragm, that's the important part. This is all enclosed, so it's airtight, with the exception of these two ports that are always trying to balance against each other. So here a capsule with this elastic properties that is airtight except for its connection to the total pressure inlet. Like a balloon, it expands its pressure inside, it increases above the pressure outside. So when you increase the pressure in a balloon as you're blowing it up, it gets bigger until the pressure inside is balancing with the pressure outside. And, of course, the balloon comes into play with that as well. As you reduce pressure, the balloon shrinks. As you increase pressure, it goes back up again, and that's how your airspeed indicator is working. Okay, here is an illustration of the pitot pressure, and to illustrate how that's functioning. So here we have a glider at rest. It hasn't started moving. Maybe it's sitting on the runway, and we haven't started towing forward yet. Our airspeed indicator is indicating 0 knots because the pitot pressure and the static pressure are the same. If those are the same, then it's going to indicate 0. Here we are, second one down. We've started towing down the runway. We're getting almost to flying speed. Your airspeed indicator is indicating 20 knots. This pressure is increasing up front here. So you have increased pressure here. Static pressure is still the same, and now you're showing 30 knots. And then here at the bottom, this would be probably on climb out behind the tow plane. We're indicating 60. The air is rushing much faster towards this pitot tube, much higher pressure, and that is indicating your higher airspeed. Still, your static pressure is the same, but this is much higher, and that's the relationship that gives you your airspeed indications. Does anybody have any questions about that? Okay. It really is. They're really pretty simple systems. They work very well, except when there is a problem. And that's this here. Here we're going into the section about problems. What are the potential faults? And the potential faults in a pitot-static system are if they are restricted or plugged. There's the pressure can no longer travel, or the air molecules can no longer travel in or out through those ports to the instrument. And that would be caused by dirt or debris in the lines or at the ports. That's why we cover up a lot of these instruments, like the pitot tube. We're going to cover it up when we're not using it so that an insect doesn't crawl in there, or dirt and mud might go in there when we're not flying. So we inspect those at our what we're doing our pre-flight inspection. Insects could also possibly block that. And here's the big one is ice, and not so much on gliders because we're not going to be flying in known icing. But one thing that you could get ice would be, now that we're doing winter operations, ice could form over these ports while it's parked. And so it's very important to make sure there's no ice restricting or blocking that. Other possible faults, although less common, would be leaks in the system, and those would be possibly a line that's loose, or maybe a line has a pinhole leak in it, or something like that. Very uncommon. It could happen after it's been repaired. Maybe someone, the mechanic, is supposed to test that stuff, but that's someplace which you need to be especially conscious of problems is after maintenance. Or if there's damage, someone was inside the cockpit, maybe kicking their feet underneath the instrument panel, possibly. That's all designed to try to be as robust as possible, but that's another possible situation that could cause a line to come loose or be damaged. So those are things to consider. Potential faults. Anybody have anything to add to that they could think of? I tried to think of all the ones I could think of. Okay, so these are your faults. These are problems that could happen with a airspeed indicator. And you have your airspeed indicator right here. And in this situation, the blockage has occurred at the pitot tube, possibly ice. Maybe it's gotten plugged with something, and you no longer have that ram air pressure entering it. Now there's a drain hole here, so it does have, essentially, it's less like a static port. So you basically have static pressure on both sides of this airspeed indicator, and you're showing 0, just like as if it were sitting on the runway and not moving. This is probably, of all the problems that you could have, airspeed is a really critical instrument to have, and you need to know it, but if it's registering 0 and you're flying, you know that you're not flying 0. So this is a problem that is probably, hey, I cannot trust this, so we're going to forget about referencing that, and we're going to use whatever other means to ensure that we're flying at the speeds that we need to get back on the ground. So blockage here wouldn't affect any of the other instruments, but it will affect the airspeed indicator, and it would get a 0 indication on that. Here is another possible fault, and in this one, the system is blocked at the pitot tube and at the drain hole. So both of them are frozen over, and you've got nothing, no air pressure change here. What will happen when this happens is that your airspeed indicator will freeze at whatever your airspeed was when this occurred. I've had this happen on a simulator that encountered icing. It was pretty interesting, and the airspeed indicator stayed the same. And but in my situation, the static port also froze. But shoot, depending, it really wasn't changed at all, and I didn't know there was a problem until it had progressed significantly. The problem with this is that this trapped air, your altimeter stops at the airspeed that you're flying at, but now it starts acting like an altimeter, and it goes up when you climb, and it goes lower, so it's showing a lower airspeed when you're diving. And anybody who has been flying here knows that when you're diving, typically airspeed increases, right? And when you're climbing, your airspeed would decrease. It's doing the opposite. And pilots have actually died. There were instrument conditions or at night, and they interpret this wrong, and they don't know that this is frozen up. And so they might be descending. They start descending, and then the airspeed drops, and they think, oh my goodness, I need to lower the nose to keep the airspeed up. They push the nose further forward. It continues to drop, and they end up crashing. So this is an instrument that's reading incorrectly is definitely much more dangerous than one that has just stopped working, because when it stops working, there's a problem and you disregard it. Any questions, comments? Okay, this is another fault, and this would be a blocked static port. This is important for you to know that when the static port is blocked, that your altimeter is going to stop working. It's going to freeze. Your VSI, your vertical speed, will also show no climb or descent because it's not getting any indication. Nothing's changing. Regardless of what the aircraft's doing, these are not going to change. And then your airspeed indicator is going to become inaccurate because it needs to have that static port to be accurate. So if a static port fails, all 3 instruments fail. None of them are going to be accurate. Keep that in mind. You need that for a question. Okay. All right. So we are to the question section, and I'm going to try to fly through this as quickly as possible because I don't want to keep you guys here too much longer. Is everybody still awake? Say aye.
Aye.
Okay. We're gonna start the quiz. This is question 3248. And let me know if that, do you see that on your Slido? Just say no if you don't.
No.
Okay, it should be coming up now. Hey, somebody made an answer. All right.
It's still not showing up for me.
You're not getting it?
Yeah,
Me
mine's
neither.
not showing up either.
All right. Interesting. Try refreshing that. What's that?
I ended up finding it. I just pressed join the quiz.
Okay, okay, all right. Sorry about that. Yeah. This is new for me too. So you had to join the quiz?
Yeah,
Yeah.
because it had
didn't
logged me out for
register
some
us.
reason.
Okay. Anybody else having a issue? It doesn't. Okay, so I've got three participants so far. And definitely just answer what you think would be the best answer. I don't know who's answering what, so I'm not going to hold it against you. But I do want to see. This tells me if there's areas that we need to cover either more tonight or later on. Okay, so it looks like we've got 5 answers in. All right, so what instrument will become inoperative if the pitot tube becomes clogged? And we had 60% said airspeed indicator, and that is correct. The airspeed indicator is the only instrument that the pitot tube feeds. All right, so we are going to go to the next question. 3249 is our next question. Let me move up. Okay, 3249. Everybody read that, see how the question pop up in your quiz. Which instrument will become inoperative if the static vents become clogged? And I've got 4 responses. Anybody having a problem with the poll? Okay, we got 5. Okay, all right. So yes, all right. So if the static vents become clogged, all of the pressure instruments are going to stop working or aren't going to work properly. So every one of these pressure instruments utilizes static pressure. Good. All right. So next up is 3262. You should have that one up on your Slido. Pitot system provides impact pressure for which instrument? Here again, pitot system provides impact pressure for which instrument? Great. Everybody got that one right. Fantastic. Airspeed indicator, pitot system. Excellent. And these are actual questions. So you are getting, if you're going to take the written exam, these are the ones you're going to see or may see on the exam.
I'm going to be honest, I'm sort of noticing a pattern of C.
Yeah, I know. I did too. And hey, so I guess if you're taking the test and you don't know the answer, you can guess with C. I would suggest knowing the answer, but yeah, you're right. C, I've read that somewhere. C is the popular choice. I don't know why that is. I think they figure that out. 3247 should be up on your screen and in Slido. So if the pitot tube and outside static vents become clogged, which instruments would be affected? Now, pitot tube and the static vents become clogged, which instruments would be affected? We have 3 answers in so far. Got all 5. Everybody got that one right. Excellent. That's right. These are your pressure instruments. All right, next one up. Let me activate that. Here we go. Which V-speed represents maneuvering speed? Okay. So this is when it looks like we've got some confusion. So let's go over this a little bit. VA can be a little difficult because VA, what is it? It doesn't really, I don't know what it stands for necessarily, but that is maneuvering speed. But these two are pretty easy to eliminate. VLO is landing gear operation, and VNE is velocity never exceed. Remember, that's your red radial line. So that leaves VA. VA is maneuvering speed. All right. These V speeds are something that takes a while. You're going to want to get a list on, kind of go over them, review them, and then you're going to learn them, and you're going to know them when it comes time to take your test. Or if you're talking to the examiner when you take your practical exam, you're going to need to know this stuff. He will ask you these questions, or may ask you. All right, so 3264 is next. Looks like we've already got one answer in here. What does the red line on an airspeed indicator represent? We got 4 or 5 answers. Everybody got that one right. Velocity never exceed. Very important speed to know. And what is that one called? It's called VNE. Velocity never exceed. All right, here we go. 3268. That one up. Which color identifies the never exceed speed? Darn it. Gave this one away on the last one. All right, everybody got that one. All right, good deal. So 3007. Here we go, another V speed. Which V speed represents maximum flap extended speed? All right, everybody got that one. Good deal. All right, moving along. VFE, velocity flap extension. All right, 3008 is next. It's live. Which V speed represents maximum landing gear extended speed? Landing gear extended speed. A is correct. I'll make sure that that's correct because a VLO is typically landing gear operating speed, and LE would land. So this is something we're going to go back and look at because I may be wrong about this. It takes a lot for an instructor to admit that they're wrong about something or maybe wrong about something. So I'll go back and verify this. Landing gear operating speed and then landing gear extension speed are 2 different things. The LE is the speed that you can have the landing gear extended, and LO, that may be a lower speed that you could operate the landing gear. So we'll go back and double check that one. So I saw the confusion and now I'm a little confused. So we'll refer back and we'll take a look at that and see what that one is. Skip forward to the next is 3009 is our question. VNO. PNO is defined as the, all right, yep, normal operating range. That is correct. Next up, 3010, and that question's live. VSO is defined as A, stalling speed or minimum steady flight speed in the landing configuration, or B, stalling speed or minimum flight speed in a specified configuration, or C, stalling speed or minimum takeoff safety speed. Okay, looks like we got all the answers in, and we got some splits on this one. I don't know if you guys are changing your minds or thinking about it. VSO is stalling speed or minimum steady flight speed in the landing configuration. Landing configuration is with your flaps extended. You are coming into land. VSO, that's that lowest speed, that bottom of the white arc. Stalling speed or minimum steady flight speed in a specified configuration, which can be kind of confusing. That's with your flaps retracted, your landing gear retracted. That would be your stall speed clean. That would be VS1. VSO is stalling speed or minimum steady flight speed in the landing configuration. All right. 3266 is coming up next, and that question's live. What is the caution range of the airplane in this airspeed? What's the caution range for this airspeed indicator? All right, everybody got that one right. 165 right here to 208 knots. That is correct. That is the caution range. Next question, 3106. Prior to takeoff, the altimeter should be set to which altitude or altimeter setting? A, current local altimeter setting if available, or departure airport elevation. B, the corrected density altitude for the departure airport, or C, the corrected pressure altitude for the departure airport. Okay, looks like we got all the answers in. So A is correct. Remember, we're going to set that for the current altimeter setting, which we would get from the AWOS on the radio, or a tower if you were at a towered airport, or from a weather report that shows the current local altimeter setting. Or if it's not available, the departure airport elevation, that's where you set 600 on that altimeter. So we're sitting on the runway and we're ready to go behind the tow plane. That's how we usually set it. So A is the correct answer on that one. All right, next up. Oh, looks like, no, we got 3250 should be our next one. Okay, here we go. So here's your altimeters. And you can select, oh, let me get that active. Okay, so that question is active now. And you can select, what does altimeter 1 indicate? Altimeter 1, this one over here is what we're reading. Okay. Altimeter 1 indicates 500 feet. So if we started out from 0, these would all be at 0. Move 100, 200, 300, 400, 500. That's your hundreds now needle right there, right? And this is the thousands, and we're halfway between 0 and 1,000 would be 500 here. So you see, we're basically seeing it 2 places, right? Okay, so next up, altimeter 2. Get that question up, 3251. That one should be live. Now we're looking for altimeter 2. What does altimeter 2 read?
I haven't seen that tiny arm before. What is that?
The little one on this altimeter, see, this is a different style. This is the 10,000s.
Thank you.
Tens of thousands, yeah. That on the first one we looked at had a skinny one, but it went all the way out, had the little reverse triangle on the end. But that's the 10,000 feet. And you can see here it also says 10,000 on the inner one, and 1,000s on this one. It kind of helps a little bit. And then here, that's kind of cool. It says, I like this altimeter. It's 100 feet on that. It says hundreds of feet out here on this outside scale. So this tells you your scale of your various needles. Okay, all right. So yes, it's 14,500 feet is what this is indicating. This tells us we're above 10,000 feet because this is the tens. So we're above 10,000 feet, we know that. So it's got to be 10,000, and then here's 4. So 10 plus 4, 14,500, 14,500 feet. All right, next up, 3253. 3253 is live. 3253, which altimeter indicates more than 10,000 feet. So one of these 3 indicates more than 10,000 feet.
You want back a slide?
Go back a slide? Oh,
No.
did I?
Yeah.
Oh, sorry about that. My mouse is getting a little twitchy here. Which altimeters are indicating more than 10,000 feet? Okay. Yeah, 1 and 2 is correct. And I'm trying to get a little tricky here, but yes, you are. That one's 10,000. You're just a little over that 0, 10,500 on that one. This one here is 14,500. Okay. 3389. 3389. The work condition is pressure, altitude, and density altitude the same value. These are used for calculating aircraft performance only. Okay. All right. So the correct answer is C. That is standard temperature. So remember, density altitude is pressure altitude corrected for non-standard temperatures. So that is all density altitudes. You're taking your pressure altitude and you're correcting it for non-standard temperature. And that's C would be, they would be the same if the temperature is standard. All right. So that is the end of the question and answer section and the end of the ground school course. Let's see here. Bring it back up here. And stop my video screen. Okay. All right. So that is it. I hope this information was helpful. I hope you learned something from it. If you see points in there that you have confusion about, I would be happy to discuss it with you later. If you want to email me, everybody should have my email address. And then go back to that section. Everything we discussed in there should have been in that section of the glider flying handbook that was assigned. I don't know. So we wanted to check that one question. I guess maybe I'll check that out, that one question, and I'll email everybody and let you know what the correct answer was. But I think you guys did pretty well on the whole. So any thoughts, any questions, any feedback? Vinny? Good. All right, cool.
I was wondering, was there a I mean, there probably is, but is there a thermometer on the glider?
You know what? I don't believe there is a thermometer on the glider.
The AWAS tells you though.
I'm sorry?
The AWAS tells you though.
Yeah, that's right. You can pick up the local temperature from the AWAS. That's right. A lot of airplanes do have a thermometer to tell you what the temperature is, especially something, a more advanced airplane that you're flying at altitude. You have to use that to calculate your true airspeed at altitude. But to be honest, I don't think the glider does. Does anybody else remember seeing one in the glider? The K-21?
No.
Any other questions? So I don't know if you guys watch YouTube or anything. Did anybody see there was a recent video that came out from New Zealand about a glider that was flying a ridge in New Zealand, and they flew into the clouds and lost reference.
I heard about it, but I didn't see it.
Yeah, I would recommend that you look that up. In fact, there's a guy he's an airline pilot that does some excellent videos on YouTube. He analyzes accidents, and he's really has a lot of great insight. He's not a glider pilot, but on his channel, actually, he went to Williams Soaring Center and was introduced to gliders, and he flew our glider before we bought it, our K-21. So it's featured in that video. What I might do is send the links to that video, and then the link to the video where he comments on the glider incident, near very, very close to a deadly accident, and they made a mistake of flying into the clouds. Gliders are not equipped for instrument flight. If you're in instrument flight, you need to have gyros and an airspeed indicator, and they're not going to keep you alive. So that's very interesting. He comes out of the clouds right at the top of the ridge. He got blown behind the ridge, and there was a lot of sink, and he was descending, and it was a really bad day. So I will send that link out. It's something that everybody should watch. It's very similar to the ridge that we fly in, of course, and there are clouds. It definitely, as that air is rising up the ridge, I don't know if you guys have seen it, as the air it might be clear at the bottom, but as that air comes up the ridge, it reaches its dew point, and then you'll see the clouds forming. So it's very similar to that, but and of course we stay well away from the clouds. But this was a bad decision, so I would like to send that to you guys so you can watch it. And if anybody else has any questions for me, I hope this was useful to you. It's my first time teaching a ground school course as a glider instructor, so I'd appreciate any feedback that you have for me, anything that I could do to improve it. And we're going to try to, we're putting together an entire ground school course, probably taught by myself and some of the other CFIGs via Zoom. So this was kind of a proof of concept, see how it all worked. And so, yeah, I appreciate any feedback you have for me.
This was super helpful. Thank you.
All right, thanks a lot. I appreciate that.